Today's tutorial is about squares or square numbers, square roots, and perfect squares, which is an introduction to the Pythagorean theorem unit. Let's begin by defining what a square number is. So by definition, a square number is the product of the same number by itself. The word product tells us that this is an answer to a multiplication question. So in order to find a square number, we have to take a number such as 6, and we have to multiply it by itself to get 36. 36 is a square number because it's the product of a number multiplied by itself. We could take another number, such as 7 times 7, which is 49. 49 is also a square number because it's the product of a number multiplied by itself. We don't have to pick only whole numbers. We can also pick decimals, such as we could say, we could do 2.2 or 2 decimal 2 times 2 decimal 2, and we get an answer of 4.84. 4.84 is a square number because it's the product of a number multiplied by itself. Another way of thinking about this is to think of a square and finding the area of a square. So the area of a square is side times side. So here we have a square that has side lengths of 3 units. To find the area of this square, we would do 3 times 3 equals 9. 9 is the area of this square, and it's also a square number because it's a product of the same 2 numbers. Again, we could pick a square that has decimals as a side length, such as this one, where we have 3.4 as 3 decimal 4 as our side length. So we could do 3 decimal 4 times 3 decimal 4 to give us 11.56. 11.56 is a square number because it's the product of the same 2 numbers, and it's also the area of this square. Sometimes when working with square numbers, you're going to be asked to square a number. You might get instructions that look something like this, where it says, square the following numbers, 5, 8, and 12. So what does that mean? What does that look like? If I'm being asked, let's start with the number 5. If I'm being asked to square the number 5, I could think of that as 5 exponent 2. That's exponent form. Expanded form, this means 5 times 5. And the standard form, 5 times 5 equals 25. So what you're being asked to do when you're squaring a number is you're being asked to find the product of that number multiplied by itself and find the square number. In this case, that would be 25. For 8, exponent form would be 8 exponent 2, which means expanded form, that's 8 times 8. And in standard form, 8 times 8 equals 64. If you're being asked to square the number 8, you're going to get an answer of 64, which is the square number. And finally, we have 12. 12 in exponent form is 12 squared, which means 12 times 12. And 12 times 12 is 144. So if you are being asked to square the number 12, you would say the answer is 144, which is a square number. Let's talk about square roots. A square root, by definition, is one of 2 equal factors of a number. So let's take the number 16, for example, and let's find the factors of 16. So the factors of 16 are going to be 1 times 16, 2 times 8, and 4 times 4. And by definition of a square root is one of 2 equal factors of a number. So the 2 equal factors are 4, so we'd say the square root of 16 is 4. And in math, we have a symbol for that. It's called the radical symbol. That's this symbol right here. And so if I take the number 16 and put it inside the radical symbol, that means to find the square root of 16. And I would say that the square root of 16 is equal to 4. Let's do this with another number. For example, let's take the number 36. So here we have 36. And again, let's find the factors of 36. So the factors of 36 are going to be 1 times 36, 2 times 18, 4 times 9, and 6 times 6. And again, by definition of a radical number, of a square root, one of 2 equal factors. So the 2 equal factors of 36 are 6. We say the square root of 36 is 6. And again, you can see that could be written with the radical 36 inside the radical sign, which means find the square root of 36. And we'd say the square root of 36 is 6. You can also find the square root of numbers that are not whole numbers. For example, this decimal here, which is tells us to find the square root of 2.25. And I'm not going to write out all the factors, but we could say that the square root of 2.25 is 1.5, because 1.5 times 1.5 is equal to 2.25. The last thing I'd like to talk to you about in this tutorial are perfect squares. And let's begin again by defining it. A perfect square, by definition, is a number whose square root is a whole number. Let's look at a couple numbers, for example. So here we have the square root of 169, and here we have the square root of 127. The square root of 169 is equal to 13. 13 times 13 equals 169. And the square root of 127 is 11.27 if we round it to the hundredth place value. So this means that 169 is a perfect square because its square root is a whole number. And 127 is not a perfect square because its square root is not a whole number. Let's look at these numbers over here that are already up on the screen. So here, starting with square root 1 and up to square root of 36. Let's find the square root of these numbers. Square root of 1 would be 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. And square root of 36 is 6. These numbers are all perfect squares. And there are 6 more here that I'd like you to pause and find these remaining 6 perfect squares in sequence. And then you can check your answers with mine. So the next one after 36 would be 49. And the square root of 49 is 7. And then we would have 64. Square root of 64 is 8. And then we'd have 81. Square root of 81 is 9. And then we have 100. Square root of 100 is 10. Then we have 121, which is a square root of 11. And finally, 144, which is a square root of 12. These numbers are all perfect squares, and it'd be useful for you to have these memorized, especially moving forward into the Pythagorean theorem.